The search for a viable energy source to meet our growing needs requires tremendous research and expertise. Experiments such as the Beverly Solar Photovoltaic Project in Beverly, Massachusetts, are helping meet our needs for alternative energy sources. At Beverly High School, a visitor center has been established to inform students, industry, and the public about the project. During the next half hour, solar energy consultant Catherine Hammond will lead us on a unique tour of the project.
Good morning and welcome to the Beverly High School Solar Photovoltaic Project. This morning we're going to be speaking about photovoltaics, sunlight making electricity. The first thing we should think about is sunlight. That's what makes the whole thing work. The second consideration is that there are no moving parts involved with photovoltaics. There is no fluid in the collector. And the third thing is that I would like you to remember that up on that hill where those subarrays are located, electricity is being made in DC form. We cannot utilize it in that form. We must use AC here at the high school. So later on in our tour, we will visit the inverter house, and that is where the electricity is converted from DC to AC and funneled into the high school for us to use. This module, which was manufactured by Solar Power Corporation of Woburn, is one of 3,200 that exist on site. It is capable of producing 34 watts of electricity and contains 36 photovoltaic cells, each interconnected on a completed circuit. It is aluminum wiring that runs through each cell, forming the circuit. This is one photovoltaic cell, very, very fragile. And it functions just like a battery. The positive charge is the top surface, and the bottom is the negative. The top surface of the module is made of glass, and with an impact would shatter just like a car windshield. The back is a mylar plastic. The cells are sealed within very tightly, and it is impossible to get them out. Over here we have 10 of our photovoltaic cells on a panel, and it too is a completed circuit. We will pretend that these lights represent the sun, and when the sun shines on the collector, it produces some electricity, and you can hear the radio. This is the best volume we get from our radio, but this would be maximum sunlight. And as clouds pass over the site, cuts down on the amount of electricity that's being made. And if it's a rainy day with minimal amount of sun, a minimal amount of light, nothing is happening there, no electricity. This is one photovoltaic cell. If it is not in touch with sunlight, there is no activity. But once it comes in contact with the sunlight, there is considerable activity, provided it is full sun. Works the same way. If clouds go by, cuts down on the amount of electricity. And if there is no sunlight, as I say, no activity. Now, since it's a completed circuit, if something interferes with one of the cells, and I'll block it off here with the magazine, it shuts down the whole system. That's pretty neat. See it again. And it can be any cell. All right? Any questions about this? May I have the lights, please? This simulator, which was designed by Stone & Webster Engineering, illustrates a 150 kilowatt field. Beverly is a 100 kilowatt installation. We completed 2 fields at the end. We exhausted our funding at the end of 2 fields. This morning we're going to look at the position of the sun in the sky at various times of the year and various times of the day. We will start with the vernal and autumnal equinoxes, March 21st and September 21st at noon, when we are capable of producing 95 kilowatts of electricity. By 5 o'clock that afternoon, we're still producing 29. When we move on to June at noontime, we are capable of getting 92 kilowatts of electricity, and at 5 o'clock in the afternoon, 42 kilowatts. It is at this point that I would like to emphasize the point that many people come here with a misconception that we get the best results in the summertime. And the reason that we do not is the fact that the summer sun's heat, this is where the heat of the sun enters into the concept of how this process works. And the heat of the sun has a negative effect on the collectors. It makes them far less efficient. So the best results are spring and fall. Now we move to the winter sky, December 21st at noon, and we're capable of getting 69 kilowatts of electricity, and by 5 o'clock that in the afternoon, we're capable of getting 8. I would like to call your attention now to our computer. May I have the lights, please? This is the on-site data acquisition system known as the ODAS. It is a computer in direct hookup with Boeing Computer Service in Seattle, Washington. It is capable of producing hard copy information. The first 7 lines of data concern themselves with weather conditions, namely wind speed, wind direction, peak winds, barometric pressure, cumulative precipitation over the course of an hour, temperature, Celsius and Fahrenheit, and barometric pressure. The next 7 lines concern themselves with insolation, I-N-S-O-L-A-T-I-O-N, insolation, the amount of radiant energy that strikes the Earth's surface, either in direct or indirect form. It is also broken down by field so that we know how much power is coming in on the A field and how much is being sent into the high school from the A field, and likewise we know how much is being produced by the B field and how much the B field is sending to the high school. The computer is also capable of presenting to us each morning yesterday's data as it appears at midnight. So the computer automatically produces at midnight one of these printouts that is available every morning. And we see various points that are charted and graphed here, all having to do with the weather information and the insolation readings. You can understand that this peaks at noon. This would be noontime. So here we start with dawn, and we progress from 6 a.m., 8 a.m., 10 a.m., noontime, 2 p.m., 4 p.m., 6 p.m., and we're even producing something here close to 8 in the evening, now that we're coming into the summer sky. Now, are there any questions about what we've talked about this morning? Yes?
What happens to electricity that is produced after school hours and on weekends?
Okay, fine. That's a very good question. Any electricity that is made during weekends and after school that is not used here by the high school itself goes through our power lines into the Mass Electric lines. And Mass Electric has a procedure by which they buy back from us the amount of electricity that they receive. Anyone else? Yes?
What about student involvement in the project?
We were very fortunate this year. As a matter of fact, we've had several of our physics students involved using some of our subarrays and repositioning them at various angles. All of these subarrays on the site are positioned currently at 50 degrees, and some of our physics students were able to take one subarray and lower it to 40 degrees and another subarray to 10 degrees. And then they took data from that for comparative studies. And we've also had some of our students using modules for experiments in conjunction with our science fair this spring. Any other questions? Yes?
What is the life expectancy of a module?
The modules are designed to last at efficiency close to 20 years. Yes?
Why was Beverly chosen for this project?
Beverly was chosen because of its location close to the Atlantic coast, the fact that we experience very cold winters, considerable amounts of snow on occasion, and we also are subject to strong hurricane winds. Also the fact that this high school operates 11 months of the year because of our summer school program, and the principal reason, the fact that we're on a hill that faces south, so we have a perfect exposure here. Well, the last feature today is a video presentation which was written, produced, and directed by Stone and Webster using students here at our high school 2 years ago. And the gentleman who plays the teacher is a professional actor. This runs about 12 minutes. I hope you enjoy